Alright, this is the second video for the Activity 121 Car Buzzer project, and in this video I'm going to show you the MultiSIM wiring schematic to build this circuit physically. This is step 6 digitally. I'm not actually going to build the circuit by hand, but I'm going to build it in MultiSIM using the IC chips and using their pinouts. So this document here is going to be very handy for me. Now, if you don't have something like this, remember when you were tasked to make a cheat sheet in class, I highly encourage you still do so, because this is your layout for your IC chips. We can see the AND gate here, the 74LS08, the OR gate, the 74LS32, and the hex inverter, 74LS04. Knowing those gates, let's switch to MultiSIM and begin building. So in MultiSIM, my circuit is still the same. I've deleted all the logic gates, and I've replaced them with IC gates. Now these are just like the physical IC chips you have when you build your circuit. Pin 1s through 7 on the left-hand side, pins 8 through 14 on the right-hand side. And now notice the VCC and the GND. If I go to my reference image, this is the LS04. If I look at the LS04, pin 14 should be VCC, my voltage common collector, my 5 volts in. Pin 7 should be my ground, and it is. And that notch indicates the orientation of this chip so that I know which pin is pin 14. That doesn't exist in here, however they are still labeled VCC and ground. So the first step I'm going to do is connect these all to VCC. Now you can do this in whichever manner you prefer. What I'm going to do is just drop in a VCC up here and a ground down here and just connect all 3 of these chips. So I'm going to search for VCC, place it somewhere up there, and I'm going to search for digital ground and place it somewhere down here. Now because these are integrated circuit chips, they have to be powered. That's not saying I'm powering pin 1 and pin 2 or pin 3 and pin 4. I'm powering the entire chip through pin 14 and pin 7. Pin 14, my VCC, I'm going to do something like this. And again, do whatever you prefer here. But that is how I would connect these. Same thing for my ground. Connect my grounds all together. And there we have it. Now this IC chip is receiving power, 5 volts VCC, my high signal, and 0 volts ground, my low signal. Now I have to follow my Boolean expression. I know that my Boolean expression is B equals K and D or not S. Looking at chip number 1, this 74LS04N, I know that that is an inverter chip, and it has the following inputs and outputs over here on the right. Pin 1 is an input, and pin 2 is the inverted output. So knowing that, I know I need to invert S. So I'm going to take my input, which is 1A, and connect it to S. Now, that means that going into pin 1A is S, and coming out of pin 1Y is going to be not S. Now, I don't know where I'm going to put this yet, so I'm just going to draw it down there for now, and I'm going to label it not S. Now, I know it's D or not S, and I know that OR gates are 32s, or IC chips are LS32s, and they have the following internals here on the right-hand side of the screen. Pin 1 is the input, pin 2 is an input, and pin 3 is the output. So just like on here, we can see pin 1A, input, pin 1B, output. Pin 1B, input, pin 1Y, output. So to reiterate, pin 1A, input, pin 1B input, pin 1Y output. So my statement says D or not S. Well, I know I need not S in that OR gate, so I'm just going to draw him up over to one of my inputs, like so. So now if I follow this not S, and I'm going to label it, I can follow it all the way over here to my IC chip in 1B, not S. I also need to retrieve D, which is my dark green line here. So I'm going to draw a wire from pin 1A all the way over to D. Now you could take your time and make this look really nice and very orderly and very clear. However, that's not the scope of the project for my purpose, so I'm going to encourage you to do whatever makes the most sense to you. You can see I can clean it up a little bit, but I don't need to go crazy with it. Alright, I have not S or D right here going into this LS32 OR gate. Now my output is here, it's 1Y, and I'm going to draw it down over here somewhere. I'm going to type text and say that this is D or not S. And I'll move it to where I can see it. And let's see if I can make this a little better here. Yeah, not really. Let's put that guy up there. There we go. So now coming out of pin 1Y is an output, is D or not S. I'm going to change the color of this wire just so I don't get confused. I'm going to change it to like this ugly snot yellow color and say okay. And as a matter of fact, I'm also going to change this from, see how S is a dark blue, I'm going to change not S to a lighter blue. Still not very light, but a lighter blue. So now I can see a clear difference. Here's S, here's not S. Here's D, here's D or not S. I'm almost done. My last section is K and D or not S. My LS08, my 74LS08 is an AND gate, and it has the following pins here on the left. Pin 1, input. Pin 2, input. Pin 3, output. Pin 1A, input. Pin 1B, input. Pin 1Y, output. Knowing that, let's connect pin 1A to K, my key. Now, because I have this VCC of red up here, I'm going to make my VCC a very dark red so that I know that there are two different wires here. So here's K, and I'm going to make sure I label this pin input over here as K. And then I have to bring in this D or not S. I have to bring it into pin 1B. So now I have K and D or not S, which I'm going to attach right here. My output is pin 1Y. So actually that D or not S isn't in the most ideal spot. Let's move some things around here so that I can hopefully do this. D or not S and K. Alright, pin 1Y, my output. I'm going to draw it for now just down out of the way, all the way down here. And I'm going to label it K and D or not S. And I'm going to make it a nice dark purple color so that I know it is my output. So you can see how messy this is starting to get. I have all of this workspace, so why would I not use it? Definitely use your workspace. It is only to your advantage to space things out so that you don't end up with any confusion like my circuit could potentially have right now. But I know that on this purple wire, I have K and D or not S, which matches my Boolean expression. So I have to take this purple wire into my output, which is all the way over here, and there is my completed circuit. Now, because of all this nonsense here, I'm going to try and clean it up. There we go. I've got my purple wire going all the way out to my output. And if I press play to simulate, start at 0, 0, 0, the only time I should have an output is at 1, 0, 0, 1, 1, 0, and 1, 1, 1. So let's check that. 0, 0, 0. Pay attention to my output. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0 should have output. 1, 0, 1 should not. 1, 1, 0 should, and 1, 1, 1 should. Great. My circuit works as it should. So now I know on my breadboard I need an LS04 IC chip, an LS08 IC chip, and an LS32 IC chip. And I need to connect them in some fashion like so. Spread your circuits out. Do not use up the smallest amount of space possible because you like being conservative. Take up the entire sheet if you need to. It only helps you. That is how you use MultiSIM to simulate using both logic gates and IC chips.